All right, so 5 points. Theorem of calculus. Sounds pretty important. All right, so there are two different parts to it. There's part 1, part 2. We've already been working with part 2. So fundamental theorem of calculus says that basically derivatives and integrals are inverse operations of each other. So if you do integral of, let's say, 2x plus 5 from 1 to 6, we can evaluate that doing capital F of x minus capital F of 1. So finding the antiderivative of the function, it would be x squared plus 5x, and we're evaluating it from 1 to 6. So it would be 6 squared plus 5 times 6 minus 1 squared plus 5 times 1. So 36 plus 30, 66 minus 6, looks like. So we get 60. So this is part 2, where you evaluate integrals using antiderivatives, and the result is the amount of area found between the curve, or in this case line, and the x-axis. So we get 60. So that's part 2. And we're going to spend a lot of time on part 2 the rest of the year. But I'd like to introduce you to part 1. So part 1 of the fundamental theorem of calculus, if we wanted to integrate, let's say from negative pi to x, cosine t dt, and I wanted to find the derivative of this. So the example, if it's y equals that, and find dy dx. So we're finding the derivative of the integral. How long has that been out of focus? Okay, so we're finding the derivative of the integral. So we could find the antiderivative and then find the derivative of it. So we could do that. So antiderivative cosine is sine, and we're evaluating it from negative pi to x. So then we plug in x in. So notice these are two different variables. That's intentional, because if this was an x, we would have sine x here, and we would be putting x in for x, which would be different variables, and we would be overusing the variable x. So t is what is on the inside, so then we can replace our t with our x. So we get sine x minus the sine of negative pi, which is 0. So we end up with sine x. Okay, so remember, that's just what y is. We need to find the derivative of that. So we need to find the derivative of sine x, and we get cosine x. So that's our answer, and that is the long way of doing it. That should always work. But remember, derivatives and integrals are inverse operations. So all we really needed to do is replace our t with an x, and we get cosine x. Now this negative pi, as long as that's a constant, you can see that our antiderivative is going to be some constant down here, and then we're going to find the derivative of it, so it's going to become 0 anyways. So that could be 1, it could be 100, could be pi, it could be anything. As long as that's a constant, we can ignore it and really just drop in the x into our expression here, so it would be cosine x. We don't have to find the antiderivative, because then we're just going to find a derivative again, and we get x. Okay, so short way, if I have y equals integral of t squared minus 5t dt from 3 to x, and I wanted to find the derivative. The answer, since that's a constant, and that's x, we could just drop in our x, and our answer is not t, x squared minus 5x, and we're done. Okay, so remember, I'd say the most important part, I mean, students catch on to this really quickly, and it's not all that difficult, but you need to understand what exactly we're doing. This is the type of problem when we're finding derivatives of an integral. Okay? It's not asking you to evaluate that integral. Then you would get this answer right here, or sine x. Okay? They're asking you, or I'm asking you, to find the derivative of an integral. And if that's the case, we use the fundamental theorem part 1. When you're finding the derivative of an integral, fundamental theorem part 1. Alright, so it does get a little bit more difficult. So if I go from 2 to x squared, and let's say it is square root of t dt. Okay, so this is what y is, and we're trying to find dy dx. So we could find the antiderivative and then find the derivative, but we can just drop it in as long as there's a constant on the bottom and variable on top. So we're going to take that x squared and we're going to drop it in, and it becomes the square root of x squared. Okay, but since this is x squared, remember we're finding the derivative. Since it's x squared, because of the chain rule, we have to multiply by 2x afterwards. Okay, so anytime this is an x, you have to multiply by the derivative of this. 1. So since it's x squared, we drop in the x squared, but then you multiply by 2x, and that is our answer. And the square root of x squared, well, it looks like x because they're inverse operations, but it's actually the absolute value of x. That's just specific to this problem. That is the definition of the absolute value of something. The square root of x squared is the absolute value of x. Okay, so another one, if I have from 10 to x cubed of 3t plus 1, and we want to find the derivative. Okay, derivative of an integral, we can just drop it in, so it's 3x cubed plus 1, and then times the derivative of that, which is 3x squared. And you could distribute 9x to the 5th. Okay, so if there's something besides x, we put it in there. Other kind of scenarios, if I have x on the bottom, I'll go 2x on the bottom, to 10, and I'll say sine of t dt. And we're finding dy dx. Okay, so we notice that the 2x is on the bottom, the constant is on top, so we can change it or flip it, so that becomes 10 to 2x sine of t dt. But if you change these, just like going from a to b, you can go b to a, but then you have to just make it negative. Okay, so if you change the boundaries of integration, it just negates whatever answer you get. So now we're ready to drop in the 2x, so we get sine of 2x times the derivative, which is 2, and it's negative. Sorry. Negative. Alright, one other scenario, if I have, let's say, from x squared to x cubed of t plus 4. And that's what y is, and we're finding dy dx. So we're finding the derivative of an integral. Okay, so we have x's on both of them. So we drop in the x cubed, so we get x cubed plus 4 times 3x squared because of the chain rule. But since there's this on the bottom, we're going to subtract that. So then drop in the x squared, so x squared plus 4 times 2x. So you just do the top times 3x squared minus the bottom times 2x, and then you could just simplify that, whatever that turns out to be. So most of those were all fundamental theorem part 1. My first example was part 2, where you just evaluate an integral using antiderivative. If we're finding